with the beginning of summer, we have beautiful warm nights, hopefully clear conditions for us to observe the stars over our heads. This map gives you a picture of what the sky would look like around about the middle of December. The center of the chart is directly over your head. West on the right, east on the left, south at the bottom, and north at the top. So if you hold this over your head, you'd be able to see the sky. The other way to do it is to actually rotate the map so that the point on the horizon that you're looking at corresponds to the bottom of the chart. Here at the bottom we have south at the bottom, so we're looking south at the moment. But let's have a look at the sky for this month. Let's start with the west because that's where they all set. So we got Jupiter and Saturn very close to the horizon now. We've watched them during the last few months as they edge closer together, and we'll talk about that a little bit later on. But we'll lose them soon. So if you haven't had a look at Jupiter and Saturn through a telescope in the last few months, do it in the next few days in early December before they get too low in the sky for a decent view. As we move around to the southern sky from the west, we notice that Scorpius and Sagittarius have already left us. So the stars of winter are completely gone. The stars of spring, like the constellations of Capricornus, Aquarius, Pegasus in the northwest, and as we move towards the southwest, Pavo and Inara are disappearing. You'll notice that the Southern Cross just over here and the pointers have just passed their very lowest point in our southern sky, and from now on they'll start rising a little bit earlier each night. And it's always when I see the Southern Cross low in the southeastern sky early in the evening, and then Canopus getting a bit higher up, that I know that summer is definitely here. And of course, as you go further to the east, you got the brilliant stars of Canis Major with Sirius there, and then you've got Rigel and Betelgeuse in Orion, Aldebaran in Taurus, Procyon in Canis Minor. All of those stars just make the summer evening sky just so brilliant that nothing can match it. It is absolutely stunning, especially if you take the trouble to go out on a dark night away from the city and see the Milky Way rising, see all of these magnificent stars. Glorious, glorious view. Some of the other constellations that we're going to see for the rest of summer, Eridanus, the river here, very long. Not a great view from the city. The stars are all quite dim, so perhaps next time you're out in the dark sky, choose to see if you can trace your way around the sky for Eridanus. Over in the north, high in the north still, we've got Cetus the whale and Pisces the fish, and Pisces at the moment is also hosting the planet Mars that we'll talk a little bit about fairly shortly. Lower in the northern sky, really in the northwest now, we've got M31, the Andromeda Galaxy, the closest large spiral galaxy to our own Milky Way galaxy at approximately 2.5 million light years away. We'll talk about these two here, the large Magellanic Cloud and the small Magellanic Cloud, in just a few minutes. These are satellite galaxies of our own Milky Way galaxy and much, much closer than Andromeda. So let's move on. Moon phases for December. Well, if you go out there in the first couple of days of December, you'll be blinded by the full moon. So there's not much really to see in the evening sky whilst we have such a bright moon. By the 8th, when the moon has reached last quarter, it will rise around about midnight. So you have the first half of the night, nice dark sky for you to do some deep sky observing. And so that begins on the 8th, and you can go all the way through to about the 20th of December, when the moon becomes a waxing crescent again. A few days after new moon, it sets early enough that by the time it gets really dark, the moon will have set, and you can start. You can keep observing. After that, the moon gets too bright again, and you're really reduced to just looking at the moon. And when I say just looking at the moon is a fascinating object to look at. It's the closest celestial body to us. Even a pair of binoculars will show a large amount of detail. You can see craters, you can see mountains on the moon. And that's a great segue to what we're going to look at on our lunar feature of the month. And this month, it's the Cauchy Hills and the immediate environs there. This is all sitting in Mare Tranquillitatis. On this shot of the full moon here, the red arrow points to where we're going to be talking about this evening. Here's Mare Crisium there. That always stands out very clearly soon after, first couple of days after a new moon. And then, of course, here we have the crater Tycho, which is a very recent impact on the moon. When I say recent, about 600 million years. But you can see the rays that emanate from the crater where the material was blasted away from the impact. But we'll talk about Tycho on another month. For tonight, it's the Cauchy Hills, and these are, as I said, in Mare Tranquillitatis on the eastern side of this lunar sea. And of course, it's the same lunar sea that hosts the first footprints by humans on the moon, made by Neil Armstrong back in July of 1969. Apollo 11 landed on this side of Mare Tranquillitatis. Tonight we're looking at the eastern side of this lunar sea. The best time to view this area is around about 4 to 5 days after new moon. So this month, around about the 19th of December. As I said, found on the eastern side of Mare Tranquillitatis. Neil Armstrong's footprints would be around about here on that sea. Right, this sunset view, unlike the view that you would get 4 or 5 days after new moon, this is actually a sunset view, which is about 4 or 5 days after full moon. So the sun is coming from this direction, from the western side, whereas if you have a look at it around December the 19th, the sun will be coming from the eastern side this way. So your shadows will be going off in that direction. So as I said, this sunset view shows the low scarp of 120 kilometer long Rupus Cauchy, which is this one here. This is an escarpment to the west of the Cauchy crater here, which is about 13 kilometers in diameter. This gives you an idea of the scale of this photo. The scarp was pushed up several billion years ago by uplift created by a sheet of magma that pushed up from the moon's core but did not breach the surface as an eruption. So this was all pushed up. And Rupus Cauchy is very, very similar to the famous Straight Wall, which lies on the other side of the moon, on the western side, some 1,700 kilometers at the edge of Mare Nubium. And here's a picture taken by a Japanese spacecraft of the Straight Wall there, so you can see that escarpment there quite clearly. And like very low elevation formations, like this escarpment here, and this valley here, they're all best viewed when the sun is at very, very low angle, so you can get the contrast of night and shade. Try looking for those at the night of full moon, and you just will not see them at all. They are best seen either at sunrise or at sunset. So go out on the 19th of December, and you should be able to find those. These two here, Rupus Cauchy, is a very long, 210 kilometer long graben. It's created by the collapse of parallel faults. Sunset shadows there, you can see, partly fill the bottom of that little valley. You can also see a couple of lunar domes here, labelled T and W for Tau and Omega Cauchy. These two domes are actually shield volcanoes, where the material that came up from inside the moon very slowly just started to accumulate. It didn't erupt, it just basically pushed material out, and then that gradually got higher and higher. And these are only 100 meters or so high. We've also got Sinus crater on the western edge of this picture. That's only 12.4 kilometers in diameter, 2,200 meters deep. So it's very deep. That's why it's so dark in there. Very deep crater, and it's named after a Greek merchant and the patron of all astronomers, Simon of Sinus, who was a Greek merchant around about the late 1800s. And then we have the flooded crater of Aryabhata over here. You can see the eastern edge of the crater still there, but the rest of it was flooded when all this lunar sea was also flooded by magma. And it was, the estimate is around about 22 kilometers in diameter, so about twice the size of Sinus or Cauchy. So I do enjoy having a look at the moon. It's our nearest neighbour, so even a low-power telescope will show you an enormous amount of detail, keep you busy for hours and hours. So do enjoy going out there and having a look. As for the rest of our solar system, we'll have a look at the inner solar system first. Over here, you can see, if you've been following these talks over the last few months, you'll notice that the positions of Earth and Mars have changed markedly. Back in October, when Earth and Mars were at their closest, around about here. So we had Earth in this part of its orbit, Mars just over here. They were only 62 million kilometers apart there. But of course, the Earth is closer to the Sun than Mars, so it moves around its orbit twice as fast as Mars does. So the Earth is receding from Mars, and tomorrow night or in a couple of nights' time, the separation between Earth and Mars will be 97.5 million kilometres. So that's grown by almost 50%, and Mars has shrunk in apparent size from 22.6 arc seconds to just 14.4. So if you didn't get a good look at Mars a month or so ago, or a couple of months ago, you left it too late. Mars is now shrinking, and it won't be much of a view. Venus and Mercury are still morning objects for us, very close to the Sun, but Venus does make a close encounter with the Moon later in December, and I'll show you that in just a second. In the outer solar system, we got Jupiter and Saturn and Pluto all happen to be lined up. That's why when you go outside at night now, you'll see Jupiter and Saturn getting ever closer together. Pluto is in the same area, but of course so much fainter that it's impossible to see other than with very large telescopes. As I said earlier, get your very last look at Jupiter and Saturn just in the next few days before they get too low in the western sky for any decent viewing. You'll still be able to see the rings of Saturn and the cloud belts and the moons of Jupiter quite well. If you do it in the next few days, after that, it's really too late. And here we go. Here's a scene from around about the 17th of this month in December. Very low in the western sky. You can see the sky is still a little bit light from the setting sun, and you have Jupiter and Saturn very, very close together, and the thin crescent moon. Only a couple of days old. That'll make quite a nice view in binoculars. You'll actually be able to fit all three of those within the field of view of a pair of binoculars, as this view shows. So there's your crescent moon, and there's the two planets. Now, just remember that these two appear close together. It is just a pure line of sight event. Saturn is actually twice as far away as Jupiter is. A few days later, on the 21st of December, the two planets will have edged closer together again. Remember, it's just a line of sight thing, but the separation between them is only 6 arc minutes. The moon is 30 arc minutes. The full moon is 30 arc minutes in diameter. So we're talking about a fifth of the diameter of the full moon. So they look very, very close together. And even with a powerful telescope, if you're able to get that low, it's only 13 degrees above the horizon. So you're going to make sure you got yourself a very clear western horizon to see this. But if you can manage that, look at them through binoculars, and if you've got a telescope, have a look at it, because you're not going to see this for a long time. You'll be able to see Jupiter, Saturn, and some of Saturn's moons and some of Jupiter's moons, all visible in the same field of view. This is simulated for my telescope at 150 times. So it's they're very close together. It's the closest they have been since 1623, and the next time you'll get them this close is in 2080. Hopefully, many of you watching this will still be around in 2080. I think I'll just be pushing up daisies. The other bright planet in the evening sky at the moment is the planet Mars, visible high in the sky within the constellation of Pisces. As I said earlier, Mars and Earth have passed their closest approach now, almost 2 months ago. So it's receding. Mars is getting further away as we're leaving it behind, and getting fainter as well, although it is still a very bright object in the northern sky. You can't miss it. Beautiful, bright red star. But we saw it back in October with a size of 22 arc seconds. Unfortunately, the next time that the two planets come close together again, on the 1st of December in 2 years' time, so exactly almost 2 years to the date, the maximum size that Mars will have is 17.2 arc seconds. For you to get at least to near the size that we saw a couple of months ago, you've got to wait till September 2035. Should you be able to have a look at Mars through a reasonably large telescope, have a look at this website from Sky and Telescope. It actually gives you a map. You give it your date and time when you're observing, and it will show you the features on Mars that you should be able to see through the telescope. So Sky and Telescope Mars Profiler, great tool to use before you go out there. And here's two pictures of Mars taken almost at the same time. You can see this exactly the same features in both. But this is the effect that the quality of the atmosphere that you're looking through has on the view that you'll get. Obviously, on the right-hand side here, the picture is a lot fuzzier than it is on the left. That is purely the difference in atmospheric seeing. The higher you look at Mars, when it's higher in the sky, the better viewing you'll get. The lower it gets in the sky, the more atmosphere you have to look through, and the fuzzier the image will be. If we go to our morning sky now, on the 13th of December, before sunrise, you'll be able to catch the 27-day-old moon and Venus less than 2 degrees apart. Again, you can capture both of these in the field of view of your binoculars quite easily, and they'll make quite a spectacular sight, even with the naked eye, with Venus being so bright. But this is the view that you'll get with a pair of binos. Again, a very thin crescent moon, and a beautiful bright Venus. Always a nice sight. So make sure you get up a little bit earlier than you normally would on the 13th of December and have a look at them. Make sure you got a nice clear eastern horizon. Now we go to our dark sky and start looking deeper into our sky. And remember, I showed you the large and small Magellanic Clouds in the all sky chart at the beginning. Well, here they are. Here's the large Magellanic Cloud, pointed to by this red arrow, and this other red arrow here points to the small Magellanic Cloud. They were named after the Portuguese explorer Ferdinand Magellan, who first saw them whilst he was exploring the South Pacific during one of these circumnavigations of the Earth back in the late 1500s. Both of these are external satellite galaxies of our own. They actually orbit around our own Milky Way galaxy, and there is interaction between these two and our own Milky Way galaxy. There is a bridge that astronomers have found of gas and stars that stretch all the way from these guys to our own Milky Way galaxy, and our galaxy is actually cannibalizing these two. In about 2.4 billion years, the Milky Way will absorb the large cloud entirely. But let's talk a bit more about both of those. Here's a close-up picture of both of them in in the sky. Here's the large cloud. Here's a small cloud, and this other little fuzzy object on the right-hand side. We'll talk about this one as well. This is a foreground object, part of our own Milky Way galaxy. So let's have a look at the large cloud first. As I said earlier, satellite galaxy of our own Milky Way galaxy. It's 158,000 light years away. So imagine what was happening on Earth 158,000 years ago. That's when the light from these stars started their journey towards Earth, traveling at 300,000 kilometers per second. It's got a diameter of 14,000 light years. As comparison, our Milky Way galaxy has a diameter of around about 100,000 light years. It's estimated to have around about 1 billion stars. We've got our Milky Way galaxy is estimated to have around about 400 billion stars. And in the sky, it looks quite large to the naked eye. If you can get away to a dark site, you can actually see it as this glowing cloud in the sky. It's around about 20 times the diameter of a full moon, so it's quite large. You won't even fit all of it in the field of view of your binoculars. And as I said earlier, it will collide with our own Milky Way galaxy in 2.4 billion years time. Let's move on to the small cloud now. Again, another satellite galaxy of our own Milky Way galaxy. This one is slightly further away at 199,000 light years, much smaller, about half the size of the large cloud, and doesn't contain anywhere near the number of stars. The estimate is only a couple of hundred million stars. This one you will fit in the field of view of your 7x50 binoculars because it's slightly less in size than that, around about 10 times the diameter of the moon. So you'll be able to fit all of that, including this object, in the field of view of your binoculars. And we'll go to this one now and talk about that object there. That object there is called a globular cluster. It's actually a round ball, a spherical ball of stars, of which there are, of that type of cluster, around about 120 or so, which form a halo around our own Milky Way galaxy. And they contain some of the oldest stars in our galaxy. This one is relatively close to us. It's the second brightest in our sky, and it's also one of the closest at only 13,000 light years away. You remember that this small Magellanic Cloud is 199,000 light years away, so that's much further away. 47 Tuc, as we lovingly call it, is much closer, just 13,000 light years away. Contains probably a couple of million stars, easily seen with the naked eye, just as a fuzzy out of focus star. Once you put a telescope to it, it really looks quite spectacular. It's almost twice the size of a full moon. Here's a picture for comparison. This is just a montage. You'll never ever get the full moon anywhere near that part of the sky, but this just gives you an idea of the size. It's quite large. So I think, as another man used to say, this might be your lot for this month. I hope you enjoy spending some time out there in the night sky. You don't have to dress up like a polar explorer. Just shorts and t-shirt should do it. So get out there and enjoy the view. And thank you for watching. And if you have any questions, there's my email address. Email me, and I'm happy to answer them for you. Thank you.